Good day, I am back again. This is Brother Mass. So I'm here to solve problem. In this place here, they say that prove that exponentially x is equal to x. Now for way to prove that, it means that we should justify if this statement is true. Look at what we do. Before anything, we first of all write solution, which is solution. Now for way to prove that exponentially x is equal to x, what we do, we now say that we now let exponentially x to be equal to u, or you can say let it be equal to z. You put any other thing for way to use it and justify. Now in this case, you now say that let exponentially x equal to u. It implies that u now give us exponentially x. Now this is what to do. For way to solve problem like this, we take lane of both sides. When taking lane of both sides, we have lane u will give us lane exponentially x. Now in this case, you now ask yourself, what should we do here? Look at what we are going to do here. Look, you know, in the laws of logarithm, when a power, when a number of a logarithm is raised to a power, the power will be used to multiply the logarithm of the number itself. Example, we may have something like logarithm of 2 raised to power 2. This can be written as 2 log 2. So in this case, the power of the logarithm will be used to multiply the logarithm itself. The power of the number of the logarithm will be used to multiply the logarithm itself. So in this case, the laws of logarithm is applicable to the laws of lane. So in this case, once you know your logarithm, you already know your lane, how to solve your lane. Now look at what you will do. What you now do, this will now be lane u will now be equal to lane x dot lane exponent. Now when you look at this dot, it doesn't mean decimal point. In mass, dot means a product. Now there is difference between this dot and this. When you do vectors, this one means a scalar product, but this one means a vector product. So it means that when you use this and dot to prove dot, it's going to give you a scalar. And when you use this and get the product of two vectors, it will still give you a vector. Now in this case, when you are using this, we now have that. Now you now ask yourself, how can we get this lane? This lane A. A logarithm, lane is a natural logarithm. When we are talking about a natural logarithm, the base is e, that the base is exponent. So lane is the same thing as lane A is the same thing as logarithm of a base e. And the law say that logarithm of a number to its own base, not only a number, no, logarithm of anything to its own base is 1, except 1 to its own base. 1 to its own base is undefined. So in this case, this will now give you 1. Now we now say that lane u will give us lane x dot 1. This will now give lane u will now give 1 times lane x will now give us 1 lane x, which can still be written as lane x. So this will now give us lane x. Now if you look at this, they are now identical. When you look at this now, this what we do, lane will cancel this lane. We now have that our u is equal to x. But remember that we make u to be equal to, we make our exponent of lane x to be equal to u. So you now say that recall that exponentially x is equal to u implies that u is equal to exponentially x, which is equal to x. Hence have exponential lane x is equal to x. Bye.